Okay, so remember for vectors, it's all about the magic triangle, correct? Magic triangle, and if I have two vectors here, you put your finger over there, you know that this is the cross, this is the dot. Correct? And that's to find the distance. Okay, so I have the proper formulas here already. Yeah, that's the distance. But what if you say, Mr. Pang, wow, I really don't like this cross. I always make mistake. You know, can we avoid it? Answer? See, if this formula is just finding the distance, can't you find distance another way? We see that. What is this? 90 degrees. Right angle triangle. Right angle triangle. Secondary school math. Think of. What's this? Right? So specifically, what's the a square, b square, and c square here? This distance square plus this distance square equals to this distance square. Okay, this distance I have, this distance I have, this distance I do not have. But what you realize, it is talking about the vector A. So, let me write it like this, and this is the hypotenuse. Correct, because these are all distances. If you just cross, you get a vector. Right? There we have it. So if you don't want to find this one, this is the guy that you do not want to find. Rearrange the formula. Square it and use the positive version. There we have it. Okay. Does it seem a bit absurd, this formula over here? Well, that's the kind of the price you pay if you don't wish to use cross. So let us try an example. Okay, let's do an example. Suppose. Okay, and then here I can make my magic triangle. Here's the angle. Good, I'm putting my fingers here. Then I know that this is the cross, and then this is the dot. I write down the formula properly. Yep. Now of course here is this. Yeah. Okay, then let me calculate them one by one. Okay, right, and the last one. Okay, let us just settle this A cross B first, yeah? I'll do it this side. And in this case, let's do it slowly. Okay, so this is the recap. Cover the top and super slowly go down. Cover the top. We have, okay, I'll just write them all out as it is. Okay, don't wish to make any careless mistake. Okay, do one final try 0 minus 1, yes. Negative 1, 1, yes. Yes, okay, good. B, we already know from here that B is just square root 5. So you'll be square root 3 over square root 5. I could merge them together, but I'm choosing not to. You'll see why. Okay. Now let's test to see if it's really true, this formula over here. So it says that this one is the same as square minus d square whole thing square root. Okay, over here we see that it does not resemble. Double check that I made no careless mistake. Okay, so as it stands, we seem to have a contradiction here, so we do a trace back. Okay, trace back our steps. I see that in this portion here, no careless mistake. I trace back to this and this. All is fine. Then I put the question back to here. Okay, was this all correct? Then I found for myself, embarrassingly, yeah, careless mistake. Okay, which I guess was unintended, but it's a case in point why sometimes we don't really want to do cross product. But yeah, okay, so this is supposed to be 0. Let me just correct that over here. Okay, and let's see. One thing to note, if you ask why I'm choosing not to put in all the negative, because I know that any negative number squared is already a positive. So when it comes to squaring, I just drop the negative altogether. That's just for me. Okay, you can always choose to put in the negative there if you please. Okay, so this will give 6. Alright, then we see they do indeed tally. Okay, yes. Alright, you can go and try another example. Just create any two vectors that you want. Observe, these were the two vectors I chose for myself. You can choose whatever you want, and you'll see that they will make sense. If you have a bit more time, you don't even have to choose a vector. You can use the abstracted form. Maybe that would be interesting. Solve from A. And you see, maybe you can prove that they are the same. These two are the same. The abstracted form. Then you know it's true. Right? Anyways, if you use intuition, why wouldn't it be true, right? Because Pythagoras theorem. So, okay. There you have it. An alternative formula in case the magic triangle, okay, this is as much as possible. Okay. Of course, that beckons the question, can we avoid cross product altogether? No. If you want to find area of triangle, area of parallelogram, unfortunately you can't avoid it altogether. But this one helps you avoid for the magic triangle. Okay, maybe that appeals to you. It's up to you. Again, this is not the syllabus, this is a derivation of our own. So if you want to apply it, understand the concept. If not, at least memorize the formula. Okay, I leave you with this.